cold and hot environment exacerbates brain pathology following concussive brain injury. I'm sorry I don't have where you're from, but maybe you can let us know. Put up the first. Can you put up the first?
Okay, first of all, I thank the organizers for providing me this opportunity, and I will tell you within 8 minutes that cold and hot environments affect brain pathology following brain injury. So I am from Uppsala University, and this is supported by US Air Force Research Laboratory, European Office of Aerospace Research and Development, and other collaboration from Indian University and Romanian University. Whatever I am going to present, this is my personal view, and it has nothing to do with the funding organizations or the governments we are working. Actually, blood-brain barrier is a key factor in brain injury that we are very well aware in early 80s, and at that time not many people are thinking that traumatic brain injury can also even open the barrier. And we consider that whenever the barrier is opened in any situation, whether it is traumatic brain injury or any kind of neurological diseases, the barrier is always open, leading to edema formation. So, under normal circumstances, we feel that this barrier is very tight, and in all neurological diseases, this barrier is broken down. The good thing is that we have drugs that can influence the barrier permeability. This is just showing that whenever there is a leaky capillary, not it will affect neurons only, but also the glial cells, and therefore the microenvironment of the central nervous system is altered, leading to pathology. We have a hypothesis that any kind of CNS insults affecting the blood-CNS barrier, because this is also spinal cord injuries, causing edema and various gene expressions leading to cell death. So we are working on this hypothesis and testing our models in different forms of brain injuries. The first indication that the blood-brain barrier is stopped to the tracer of lanthanum is tight junction, and was given by Brightman and Lee of National Institute of Health. This was the first anatomical evidence. And we have reciprocated in our laboratory using rat spinal cord, but lanthanum is the same. In normal vessels, it is quite intact, and the barrier is normal. So there are various data we have shown that environmental temperature affects barrier function in different areas, and even rearing temperature can affect different kinds of cellular pathology. I do not have much time to go through. And nowadays, there are evidences that even injury at cold environment, this is a thesis done on Cornell, suggesting that it will also affect the brain atrophy. And here, I don't need to tell that the brain injury is very classic and very old, but still we have not so much data to treat them effectively. As you are all aware that the most important type of brain injury comes from firearms, followed by vehicle accidents. But we are considering other aspects. We have to think that when our soldiers are exposed to hot environment in desert, they're also breathing different kinds of nanoparticles. And when they get injured, probably the pathophysiology of their brain injury is not similar as that we can have in normal situations. Likewise, if the brain injury occurs in a very cold environment, we also feel that there are different kinds of nanoparticles, different kinds of environment. They will also affect the pathophysiology. This is another scenario I'm not going to discuss. People are exposed, our soldiers are exposed to different kind of missile explosion, and they are breathing carbon nanoparticles, and it will also affect their brain function. So we try to study two different kinds of models. Here we have developed a concussive brain injury model, and where a weight of 114.6 grams is dropped over the parietal skull, and it will produce an impact of 0.224 Newton. And I must tell you that the mode of injury is very important. If there is an open injury, we open the skull and make an incision, the pathophysiological development of edema and cell injury are quite different. So I will show you some results related to this model today. I can only tell you showing the other model in which we had an open brain injury. You can see that applying different kinds of drugs can make neuroprotection. This is just for an example. And therefore, we still believe that many things in brain injury, although extensively studied, we have many more things to go, and we do not understand many things at the moment. So what we have done, we have used Sprout dolly rats, and from the age of 5 weeks, they were male rats, were exposed to another 5 weeks at different environmental temperature. So at the age of 12 weeks, we did the experiment. And these are our environmental chambers. They were set for either 5 degree plus minus 1, 23 plus minus 1 for the normal, and then 34 plus minus 1 at 5 temperature. And we wanted to study the leakage of the blood-brain barrier because the brain capillaries are different than the normal capillaries. So we focused our attention on endothelial cell permeability first because they are very high in number, and also the neurons, they could be affected. So as I told you, we have 3 different groups, and we have studied blood-brain barrier disruption, brain edema formation, and neuronal injury. Oops. Okay, this is the conversion from Apple to Macintosh, but I can only tell you here that this is blood-brain barrier permeability, and this is 5 degree and 23 and 34. But I wanted to show you that there is both significant increase from the 23 degrees Celsius at cold and also at heat. And what I wanted to show you that when injury is done at the right side, left side is much more damaging. Well, you can't see, but this is the data of brain edema, and this is the data of cellular injury. I can show you the examples. So this is the example at 34 degrees Celsius neuronal injury, and this is 5 degrees. You can see the cell damage is much more severe in both cases, and this is at 23 degrees centigrade compared to the normal levels. The same thing we tested at electron microscopy. Perivascular edema is highest at 34 and also much severe at 5 degrees Celsius as compared to 23 degree, and this is the control level. So we can say on the basis of these results that rearing temperature affects the pathophysiology of traumatic brain injury. And what are the possible causes? We still do not know, but probably the physiology of animals are altered. Maybe the oxidative stress or other factors are involved. Might be age and species variation can also play a role. So we wanted to go into the deep to understand the basic mechanisms of brain injury. It's a very short presentation, and we have some idea that some neurochemicals also are do not have time. This is our sponsors and supporters, and I thank you very much for your comment.
This paper is now open for questions.
What was the temperature when the injury was delivered, and did you maintain the temperature for the first few hours after injury was delivered?
The animals were reared at a cold and hot environment. The injury was done at the room temperature, and the body temperature were maintained throughout 5 hours.
Time for one more question. If not, we'll move on. Thank you very much. And our next